Welcome to this lecture. In this lecture, we will discuss about the nth derivative. Let's understand the nth derivative with the help of a simple example, which is f of x is equal to x raised to m. If we differentiate f of x is equal to x raised to m, it would be f dash of x and would be equal to m into x raised to m minus 1. Differentiate this again, f double dash of x, we will get m into m minus 1 into x raised to m minus 2. Let's further differentiate this. F triple dash of x will be equal to m into m minus 1 into m minus 2 into x raised to m minus 3. Let's again differentiate. The fourth differentiation of f of x would be m into m minus 1 into m minus 2 into m minus 3 into x raised to m minus 4. We can see a pattern here. With each successive differentiation, the power of x gets reduced by 1 and the reduced power is multiplied to the function, right? So in this case, for the first derivative m, for the second derivative m is multiplied from m to m minus 1, not m minus 2. So we can formulate the function for the nth derivative of f of x. We can get m into m minus 1 into m minus 2 up to m minus n plus 1 into x raised to m minus n. Here you can see this multiplier is nothing but m p n, which is multiplied to x raised to m minus n. So we have formulated the nth derivative of f of x is equal to x raised to m. But here we can see there is a condition. M has to be greater than or equal to n. Only in that case this formula is applicable, this or this. Why is that so? Let's take m less than n. This means, let's understand it. Suppose f of x is equal to x square, where 2 is equal to m, and we want the derivation f raised to 6x. We want the sixth derivative of the function x square. For the first derivation, we will get f dash of x is equal to 2x. For the second derivation, f double dash of x would be equal to 2. And for each successive derivation, the answer would be 0. Because as m becomes n, the answer gets constant. Because the variable part becomes 1. So for m less than n, the f raised to n, nth derivative of x for this particular function would be 0. And if m is equal to n, then x would be equal to 1. If m is equal to n, then the final answer would be f raised to n x is equal to m p m, because m is equal to n and this is equal to m factorial or n factorial. Let's move on to the next formula. Let us prove this formula. F of x is given. Let us find f dash of x. F dash of x would be m ax plus b raised to m minus 1 into d by dx of ax plus b. This is the chain rule. It would be equal to m into a into ax plus b raised to m minus 1. The same way, let us further differentiate this. F double dash of x would be equal to m into m minus 1 a square ax plus b raised to m minus 2. Again, differentiating f triple dash of x would be equal to m minus 1 m minus 2 into a cube ax plus b raised to m minus 3. You can see these two terms are same as the previous example, and the power of a keeps getting increased as we differentiate it further and further. If we differentiate it one time, the power of a is 1. If it is differentiated twice, the power of a is 2. And if it is differentiated thrice, the power of a is 3. So now we see the pattern. F raised to nth derivative of this particular function would be m minus 1 m minus 2 up to m minus n plus 1 into a raised to n into ax plus b raised to m minus n, and this would be equal to m p n into a raised to n into ax plus b raised to m minus n. The nth derivative would be this. Here also the condition applies, m greater than or equal to n. M has to be greater than or equal to n. If m is equal to n, this term would become 0, and the final answer would be the nth derivative be n factorial into a raised to n, because this term is 0. And if m is less than n, this would imply that we are differentiating this again, and this term is constant, and it would be 0. The nth derivative of this function would be 0. Let us go for the next formula. F of x is 1 upon ax plus b. It is given. So we can write this f of x is equal to ax plus b raised to minus 1. Let us differentiate this. F dash of x would be minus 1 into ax plus b raised to minus 2 into a. The chain rule will apply, and the differentiation of this would be a. Again, let us differentiate this. F double dash of x would be equal to minus 1 into minus 2 into ax plus b raised to minus 3 into a square. Again, let us differentiate f triple dash of x. This would be equal to minus 1 into minus 2 into minus 3 into ax plus b raised to minus 4 into a cube. You can see for the first differentiation, power of a is 1. For second, power of a is 2. And for third, power of a is 3. For the first differentiation, power of this term is minus 2. For second, it is minus 3. And for third, it is minus 4. And for the first derivative, it is 1. For the second derivative, it is 2 factorial. For the third derivative, it is 3 factorial. And we can see for any odd number of derivation, the sign of the derivative is negative. And for every even number of derivation, the sign of derivative is positive. So now we can find the formula. The nth derivative would be equal to minus 1 raised to n. Why? This is for the reason for first derivative the function is negative. For second derivative it is positive. For third derivative it is again negative. So this term represents the sign. Next, for each successive differentiation, the term is getting increased in the form of factorial. Minus 1 raised to n into n factorial into, for each successive differentiation, the power of a keeps getting increased. We can write a raised to n, and for each successive differentiation, the power of term ax plus b keeps getting decreased by 1. For first derivation, it is 2. For second derivation, it is minus 3. For third derivation, it is minus 4. So we can write it in the denominator. We will write it as ax plus b raised to n plus 1. As the power is minus, we can write it in the denominator. This is the formula for 1 upon ax plus b, the nth derivation. The next function is f of x is equal to ln ax plus b. Let us differentiate this. F dash of x would be equal to 1 upon ax plus b into d by dx of ax plus b. The chain rule will apply. The answer would be a into ax plus b raised to minus 1. Let us further differentiate this. F double dash of x would be equal to a square into minus 1 into ax plus b raised to minus 2. Again differentiating f triple dash of x, this would be equal to a cube minus 1 into minus 2 into ax plus b raised to minus 3. Again let's differentiate. The fourth derivative of f of x would be equal to a raised to 4 into minus 1 into minus 2 into minus 3 into ax plus b raised to minus 4. Now again, just like the previous example, we can see the pattern. For each successive derivation, the power of ax plus b keeps getting decreased by the second derivation, the power is minus 2. For third derivation, the power is minus 3. For fourth derivation, the power is minus 4. For each successive derivation, the power of a keeps getting increased. For first derivation, the power of a is 1. For second, it is 2. For third, it is 3. And for fourth, it is 4. And we can also see, for the first derivation, there is no term involved in here. For the second derivation, the whole term is negative and it is minus 1. For third derivation, the whole term is positive because two minus are getting multiplied, right? So we can say for every even derivative, the term is negative. For every odd derivative, the term is positive. Unlike the previous example, in previous example, for every even derivative, the term gets positive, and for every odd derivative, the term gets negative. But here, for every even derivative, the term is positive, and for every odd derivative, the term is negative. So we will write the nth derivative of f of x as minus 1 raised to n minus 1. It is subtracted by 1 because for every even derivation, this term would become negative, and for every odd derivation, this term would become positive. And that is the rate of this previous derivations. Minus 1 raised to n minus 1 into, let us see the factorial. For the third derivative, it is 2 factorial. For the fourth derivative, it is 3 factorial. We can say it is n minus 1 factorial. For second derivative, a has power 2. For fourth derivative, a has 4 power. So it is simple. A raised to n upon, as all these powers are negative, we can write second derivative power 2, third derivative power 3, fourth derivative power 4. So we can write directly ax plus b raised to n. This is very much similar to previous example. The only differentiating factor is n, right? The next formula is f of x is equal to a raised to mx. Let us differentiate this. Again, chain rule will apply. F dash of x would be equal to d by dx of a raised to mx. This would be equal to a raised to mx into ln a into d by dx of mx, and this would be equal to m into ln a into a raised to mx. You can see m and ln a are constants. Only a raised to mx is variable. So you can say for each successive differentiation, this term would get multiplied and this term will remain as it is, right? So in this case, we don't have to do any further differentiation. We can directly derive the formula. The nth derivative would be m raised to n ln a raised to n into a raised to mx, because for each successive differentiation, this term has no impact. Only this term gets multiplied. Next formula is f of x is equal to e raised to mx. The f dash of x would be e raised to mx into d by dx of mx, which is equal to m into e raised to mx. Just like previous example, the term e raised to mx has no impact on differentiating it. Only the term m keeps getting multiplied. So we can directly write the nth derivative of this function would be equal to m raised to n into e raised to mx. Now the next function is f of x is equal to sin x. To find the nth derivative of sin x, first we will see the unit circle. This is the unit circle. In the first quadrant, all the trigonometric functions are positive. In the second quadrant, only sine and cosec are positive. In the third quadrant, tan and cot are positive. In the fourth quadrant, cos and secant are positive. Now let us see how the sine behaves. F dash of x would be equal to cos x. F double dash of x would be equal to minus sin x. F triple dash of x would be equal to minus cos x. The fourth derivative of f of x would be sin x. We can see after every fourth derivation, the function returns as it is. Okay, let us understand it like this. This cos x is nothing but sin pi by 2 plus x. This sin x is nothing but sin pi plus x. This minus cos x is nothing but sin 3 pi by 2 plus x, and this sin x is nothing but sin 2 pi plus x. So now we can see the pattern here. The nth derivative of this function would be sin n pi by 2 plus x. The next function is f of x is equal to cos x. Again, we will see the unit circle here also. Now we know which functions are positive in which quadrant, right? Let us differentiate f dash of x, and this is minus sin x, which is nothing but cos pi by 2 plus x. The second derivative, f double dash of x, this is minus cos x, and this is nothing but cos pi plus x. The next derivative, f triple dash of x. This is sin x, which is nothing but cos 3 pi by 2 plus x. And the fourth derivative, which is cos x, and it is nothing but cos 2 pi plus x. We can see after every fourth derivative the function returns as it is, and we can see the pattern here. So we can write the nth derivative of the function f of x would be equal to cos x plus n pi by 2. The next function is f of x is equal to sin ax plus b. From the previous function, this f of x is equal to sin x, we know how sine works, how we can differentiate sine. For every differentiation, we just have to add pi by 2 and the differentiation is done for the particular function sine. Right? Here, only one step is extra. If we will differentiate this function, the chain rule will apply. Sine will become cos ax plus b into d by dx of ax plus b, and this would be equal to a into cos ax plus b, and which is nothing but a into sine pi by 2 plus ax plus b. Similarly, f double dash of x would be equal to a square into minus sine ax plus b, and which is, we can represent it by a square into sine pi plus ax plus b. So here also, with each successive differentiation, the pi by 2 is added in the angle, and the power of a keeps getting increased by 1. So we can write the formula. The nth derivative would be equal to a raised to n into sine ax plus b plus n pi by 2. Let us see the next function, which is f of x is equal to cos ax plus b. We have seen previous function, the a will keep getting increased, so it would be a raised to n, and in here we have already seen for each successive differentiation we are supposed to add pi by 2. It would be n pi by 2 in the angle. So let us differentiate this. F dash x would be equal to minus sine ax plus b into d by dx of ax plus b, which is a into minus sine ax plus b, which is nothing but a into cos pi by 2 plus ax plus b. Just like the previous example, now we know with each successive differentiation this would increase by pi by 2, and the power of a would keep getting increased. For the first differentiation it is 1, for second it is 2. For the nth differentiation, the nth derivative of f would be equal to a raised to n into cos n pi by 2 plus ax plus b. The next function is f of x is equal to e raised to ax cos bx plus c. This is a little tricky function to find the nth derivative. Let us see. First, we will find the f dash of x. This would be, we will apply the multiplication and chain rule. F dash of x would be cos bx plus c into d by dx of e raised to ax plus e raised to ax into d by dx of cos bx plus c. The f dash of x would be equal to a e raised to ax cos bx plus c minus b e raised to ax sin bx plus c. Hope you understand this. This is standard chain rule. We know in the Cartesian system we can write a pair of number as r cos alpha and r sin alpha. So in this particular function we will take a is equal to r cos alpha and b is equal to r sin alpha. In that case r square would be equal to a square plus b square and tan alpha would be equal to b upon a. This is what we are assuming, right? Let us put the values of a and b in this formula. We can take e raised to ax common. F dash of x would be equal to e raised to ax into the bracket. We can write r cos alpha instead of a, r cos alpha into cos bx plus c minus, we will write r sin alpha instead of b, r sin alpha into sin bx plus c. You can see inside we can take r common and the remaining terms are nothing but the formula of cos a plus b. F dash of x would be equal to r e raised to ax cos bx plus c plus alpha. This is the first derivation of the function. Let us differentiate this again. We will get f double dash of x. We know r is constant and alpha is constant. We can keep the r outside of the equation and we will apply multiplication and chain rules. Cos bx plus c plus alpha into d by dx of e raised to ax plus e raised to ax into d by dx of cos bx plus c plus alpha. This would be equal to r a e raised to x cos bx plus c plus alpha minus b e raised to x sin bx plus c plus alpha. You can see here e raised to ax we can take common and we will put the values of a and b. We will get f double dash of x is equal to r e raised to x. We can write r cos alpha instead of a into cos bx plus c plus alpha minus r sin alpha into sin bx plus c plus alpha. You can again take the common r. We will get f double dash of x would be equal to r square e raised to ax, and we can see that the remaining terms are nothing but cos a plus b formula. So inside the bracket would be cos bx plus c plus alpha. From these traits we can see for each successive differentiation nothing changes, only the power of r is increasing and the value of alpha keeps getting added into the angle, right? So we can easily write the nth derivative. The nth derivative of f of x would be equal to r raised to n into e raised to ax cos bx plus c plus n alpha. Or we can write the values of these two. R is under root of a square plus b square, and alpha is tan inverse b upon a. Let us write that the nth derivative of f of x is a square plus b square raised to n by 2 into e raised to ax into cos bx plus c plus n into tan inverse b upon a. The last function is f of x is equal to e raised to ax sin bx plus c. We will take the similar approach as the previous example. Here also we will assume a is equal to r cos alpha, b is equal to r sin alpha, and alpha would be equal to b upon a, and r would be equal to under root a square plus b square. Let us differentiate this. F dash of x would be equal to sin bx plus c into d by dx of e raised to ax plus e raised to ax into d by dx of sin bx plus c. This would give us f dash of x would be equal to a e raised to ax into sin bx plus c plus b e raised to ax cos bx plus c. We will put the values. A is equal to r cos alpha, b is equal to r sin alpha. So f dash of x would be equal to r e raised to ax cos alpha into sin bx plus c plus r e raised to ax sin alpha into cos bx plus c. We can take these two terms r e raised to x common. F dash of x would be equal to r e raised to ax into the bracket cos alpha sin bx plus c plus sin alpha into cos bx plus c. You can see the bracket is nothing but the formula of sin a plus b. So f dash of x would be equal to r e raised to ax into sin bx plus c plus alpha. Let us further differentiate this. F double dash of x would be equal to r into sin bx plus c plus alpha into d by dx of e raised to ax plus e raised to ax into d by dx of sin bx plus c plus alpha. F double dash of x would be r into a e raised to x sin bx plus c plus alpha plus b e raised to x cos bx plus c plus alpha. We can take e raised to ax common and we will put the values of a and b. F double dash of x would be equal to r e raised to ax r cos alpha into sin bx plus c plus alpha plus r sin alpha into cos bx plus c plus alpha. We can take r common and the remaining terms are nothing but sin a plus b formula. So f double dash of x would be equal to r square e raised to ax sin bx plus c plus 2 alpha. So we can see the trait of this function's derivatives. For each successive derivation, the power of r keeps getting increased and the alpha is added with each successive differentiation. So we can write the nth derivative like nth derivative of function f of x is r raised to n e raised to ax sine bx plus c plus n alpha, or we can put the values of alpha and r, where alpha is tan inverse b upon a and r is equal to a square plus b square raised to 1 by 2. So the nth derivative is a square plus b square raised to n upon 2 into e raised to ax into sine bx plus c plus n into tan inverse b upon a. You can see on the screen, these are all the equations that we have derived. We will use them as formulas to solve the questions.